All right, let's dive in. Today, we're going to talk about something that totally flips the script on how we think about knowledge. It's a field called justification logic, and it's all about this idea of moving beyond just knowing that something is true to knowing exactly why it's true. So let me ask you something. I want you to think about all the stuff you know right now. Do you, just by knowing those things, automatically know every single logical consequence that follows from them? Every possible deduction, no matter how ridiculously complex? Sounds pretty impossible, right? Well, believe it or not, for a really long time, the formal logic we use to model knowledge was basically built on this wild assumption that, yep, you're a perfect logical supercomputer. So yeah, let's dig into why that is such a huge problem. Because what it did was create this idea of a knower who, ironically, is, well, completely illogical when you think about the real world. This whole issue has a name. It's called the logical omniscience problem. It's kind of like saying if you know the rules of chess, you instantly know the absolute best move in every possible game. I mean, instantly. That was the bizarre side effect of the old way of thinking. It just assumed that anyone or any AI knew every logical truth without even trying. And yeah, this slide just lays it all out, right? On one side, you've got this ideal knower, this mythical being with infinite time and brain power. And on the other side, that's us. That's you. We have deadlines, we get tired, we actually have to think and put in the effort. It's not a small difference. It's a giant fundamental flaw in the model. Okay, so obviously this massive gap really bothered logicians, and it sent them on a search. They weren't just trying to patch up a small bug, they were on a hunt for the holy grail, a way to formally bake the reason, the why, right into the logic itself. And this search goes way back. It started with this pretty straightforward idea. For something to be truly proven, you ought to be able to show the actual proof. The legendary logician Kurt Gödel took a crack at it, but he hit a wall. His system could tell you that a proof exists, but it couldn't actually show you the proof. It was just like pointing to a locked box and saying, "Trust me, the answer's in there," but you have no key to open it.
And this, right here, is where our hero enters the scene. To finally unlock that box, to solve this mystery of the missing why, a brand new system was created, justification logic. So that old locked box, in logical terms, it looked like this. This symbol basically just says, yep, this statement is known, period. It's a declaration without any backup. It tells you that it's true, but gives you zero clues as to how we know. And then, bam, here's the breakthrough. Justification logic smashes open that box with this new notation, T:(phi). This doesn't just say a statement is known, it says it's known for a specific reason, T. That little T, that changes everything. It's the proof, it's the evidence, it's the why. And that's the whole game right there. Justification logic is all about knowledge that comes with receipts. You know, it's a logic of evidence. That T isn't just some random letter. It represents the actual concrete chain of reasoning.
Now, what's really cool is that this isn't just throwing out the old system and starting over. There's this incredible proof called the realization theorem, and it showed that you can take any statement from that old black box logic and basically unpack it, revealing the specific justifications that were hidden inside the whole time. Okay, so if these reasons, these justifications, are now front and center in our logic, how do they actually, work? How do we build with them? It's actually surprisingly simple, almost like building with Legos. Imagine you have one reason, let's call it S, that proves if it rains, then the street gets wet, okay? Then you get another reason, T, that proves, hey, it's raining right now. Well, the application operation lets you click those two pieces of logic together to create a brand new justification, S.T, for the obvious conclusion, the street is wet. There's another cool tool in the toolbox called sum. This one's even easier. It's literally just pooling your evidence. If you've got reason S for one thing and reason T for another, S plus T becomes this one big super justification that covers everything both of the original reasons did.
Okay, so let's recap. We've gone from a murky logic of just because to a crystal clear logic of explicit reasons that we can combine and track. So what does all this power really get us? Well, it gives us knowledge with a blueprint.
So what's the big payoff here? What does this unlock? First off, it completely demolishes that logical omniscience problem we talked about. No more magic knowledge. You need a reason.
Second, it forges this amazing direct link between cold, hard logic and that classic philosophical idea of knowledge as justified true belief. And maybe most importantly, we now get a detailed blueprint that shows exactly how we arrived at a conclusion. Every step, every piece of evidence, all laid out.
But why is having a blueprint so important? Who cares? Well, think about something like data privacy for a second. If some algorithm makes a decision about you using your personal data, wouldn't you want to know exactly what data it used and what rules it followed? Justification logic gives us the framework to do exactly that, to demand that every conclusion comes with a receipt.
Maybe the best way to wrap your head around this is to think of a justification like a piece of software. A program is just a sequence of instructions. That's our justification, our T, that gets you to a specific outcome. Well, justification logic is the same thing, but for knowledge. It gives us the source code for our beliefs.
And that brings us full circle, doesn't it? It leaves us with a pretty deep question to chew on. If real knowledge requires a reason, a justification, if it means you have to hold the blueprint, then what do you truly actually know?